Coming up on This Week in Radio Tech, Mark Aitken is our guest. He's the Senior Vice President for Technology at Sinclair Broadcast Group. Also, Marty Sacks with Telos Alliance is on too. We're going to be talking to Mark about how ATSC 3.0 NexGenTV relates to radio broadcasting. It's kind of interesting. It's coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support online at bgs.cc. By Broadcast Bionics with the Bionics Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts. Hey, welcome into This Week in Radio Tech, the show where we're talking about everything from the microphone to the light bulb at the top of the tower. And on this show, we're going to be talking about perhaps the light bulb at the top of a television tower. That's coming up. I'll tell you why. We're actually relating radio broadcasting in a number of different disciplines that go along with that. Technical, business, content. We're relating that to ATSC 3.0, also known as NexGenTV. I know it's intriguing. It's really intriguing what we're talking about. A lot of this stuff is real right now. A lot of this stuff is coming up in the very near future. And hey, there's even technologies that we can leverage on later on as we get this all figured out. I'm Kirk Harnack. I'm in the Telos Alliance studio in Nashville, Tennessee. Glad to be here with you and very thankful to Telos Alliance for giving me a little bit of time off on a Thursday afternoon to bring you this show and our very special guest. We'll announce the guest in just a minute. But I'm also got something very interesting happening today. When I mentioned to my boss at the Telos Alliance who my guest was this week, he said, "Oh my goodness, I would love to talk to him." Because my boss, Marty Sacks, actually he's my grandfather boss, right? A couple times removed. Marty and I have worked together for 20 years at the Telos Alliance, and he's here now. Marty, welcome into the show. Good to see you.
Hey, thanks, Kirk. Great to be with you, and no, I'm not your boss.
Well, that's right. You're my boss's boss. Oh,
one big happy
Marty, family. That's right. We've worked together for 20 years, and one of the things that you have been especially excited about and studying and going to all the seminars and even giving some talks yourself is NexGenTV ATSC 3.0. So I asked you to come on to this show because you're a radio guy, and we've got a foot in TV, and I want to understand how these two things are related. Maybe you can help us understand, why are you here? What can you add to our conversation?
So ATSC 3 is something that's fascinating to us here at Telos through our linear acoustic brand. And specifically, we make some products that help make ATSC 3 happen. One of those products is specifically designed for broadcasting here in the U.S., as a matter of fact. So it's, when you told me that Mark was going to be on, I started peppering you with questions, and next thing you know, I drew the short straw, and I'm helping you out this week. So I'm happy to be here. Thanks for having me.
Here's the list of questions. I told Marty, and we had a conversation. He said, "Here, let me ask these. I want you to ask these things right here." Oh my goodness, I got a whole paperwork. And we have the longest. This is our show prep notes for this episode. They don't even fit on one page. 2 pages worth of show prep notes. So who are we talking about, and what does he know, and what's he going to tell us? Well, I'm proud to introduce our guest today, Mark Aitken. He's the Senior Vice President of Technology at Sinclair Broadcast Group. Mark, it's a delight to have you on. Good to see you.
I'm actually delighted to be invited and excited to share many of the things that we're doing. And I heard you earlier. I'm sort of the guy who had one foot in radio, and I'm now on television. So we could talk about that later if you want.
I do want to finish up, or sometime during the show, mention how we have probably crossed paths, and a lot of our viewers and listeners have actually looked at some of your work output from many, many years ago. So we'll give people a clue into that. But let's just say you're well grounded. In fact, your grid is well grounded in radio, if I could say that.
I could probably take a broomstick with a piece of wire and draw a good sized arc.
I heard broomsticks were used to
tell about it.
And live to tell about it. Yeah. There's so much we could talk about, but I've just got to jump right in. And first of all, radio engineers, I promise you that we're going to intersect radio and the technology we're talking about, ATSC 3.0, which is, we think of that as a television technology. It's the thing that may make us buy a new TV set. And rather than go through all the introductions of that, I think we're going to hit a lot of these questions just as we move through the show. So without a lot of setup and what is ATSC 3.0, there's lots of webinars out there about that. Let's jump right in. I'm particularly interested because whenever I hear something happening with ATSC 3.0, it intersects with the name Sinclair Broadcast. And Mark, you work with Sinclair. You are very close. So you're in the, in the C-suite there. Why is Sinclair putting so much effort, research and elbow grease and putting their money where their mouth is into ATSC 3.0? What's in this for Sinclair?
Well, I think the simplest answer is it's all about broadcasting. And, if you look in the history of back in the history of Sinclair, even there was a large radio ownership for a while. We still own several radio stations, but we're focused on broadcast technology. And David Smith, the chairman of Sinclair, he's an engineer. As a matter of fact, our history literally goes back to before I was my 40-year marriage. My wife Kathy was his father's executive secretary at station number 2 that was built in Pittsburgh, and so broadcasting's in our blood. It's about serving people. It's always about the money. At the end of the day, none of us work in the broadcast industry as a charity, but it's really about extending the reach. And I have some folks might say that I've not been very, very good at it because it's taken 20 plus years to get here. But I joined Sinclair in 1999 because there were issues with the old standard. The old standard was ushered in. Folks like David Smith and many hundreds thought that that this new digital standard would allow would allow mobile broadcasting, and that didn't pan out. So the reason that you hear our name more often than some others is we've been writing checks specifically on this ATSC 3 train, for 8+ years, and we have spent literally more tens of millions of dollars than I want to talk about. But it's in the pursuit of, in a certain sense, it's in the pursuit of excellence because we want to be able to take the long century plus background of broadcasting and bring it into today's era, and so that's where a lot of this radio stuff is. It's because it's not only is it digital, but it's IP based digital. Mm-hmm. And people will say, well, we had a digital transition with ATSC 1, right? And the problem is that nobody focused on changing the nature of the business we were in. They simply put a digital encoder in front of. By the way, everybody, here's the news: RF waves are not digital. So you may have all this digital backbone, but RF waves are analog. So I could go on probably forever, but I'll take the next question.
Yeah. So Marty's got some big overarching questions, but I've got an initial kickoff overarching question. That is about help us understand what differentiates ATSC 3. And you already mentioned IP, so that's good. But what differentiates ATSC3 from the things that came before, especially ATSC1, because you hit the nail on the head there when you said, well, we just bought TVs. We've been buying ATSC TVs. I guess my first one may have come along 15, 16 years ago. But what's the differentiator technically? And then we're going to start having to talk about the user experience. And then before the end of the show, we'll talk about why the technicalities make that user experience possible. What's the differentiator, though?
Well, the differentiator is VSB, vestigial sideband, 8 VSB to be precise, versus OFDM, orthogonal frequency division multiplex, and some of the tools that are simply an integral part of the waveform provide tremendous tools in the propagation and reception environment of any RF signal. And if you look across standards globally, 8 VSB has always been an outlier. OFDM was around at, you can go into the history and politics and national industrial policy, which turns out was about, can we sell spectrum? But at the end of the day, it is the multi-carrier nature of OFDM that provides the basis to scale a quality of service. It's not a one size fits all, and one size fits all unless it's too small and it doesn't fit, and that's kind of where we ended up with ATSC1, there's always, there's an equivalence in the frequency domain and time domain. Many of your listeners will, strike a chord with, Fourier transform. But at the end of the day, the specific instantiation of VSB that we were offered was limited in many respects. And so I came to quite literally learn that in 1996. I was with a company that had recently, it was owned by a European company, and they were immersed in DVB-T at the time, and so when I came to Sinclair, I had already had a background in understanding some of what we in the early days at Sinclair called the fatal flaw, but it's about the nature of the waveforms and the ability to scale that waveform for different use cases.
Gotcha. So, what if I can get an idea of the bit rate that is available to a broadcaster under ATSC3? Is there a big honking number that you can tell me what's available to divvy up between all the different services that you may transmit at once?
Oh, well, yeah. I mean, if you're talking SIMO, single input, multi-output, or SISO, which is sort of the base of this, the raw waveform using the highest order of modulation, which is 4096 non-uniform QAM, put that together and reduce your code rates, and it's possible to broadcast in the region of 60 megabits per second out of a 6 megahertz channel. At the low end,
yeah.
By the way, you're talking about SNR or C over N operational values of 32 dB or so. But if you go to the other end of the spectrum and go to QPSK, for example, and high code rates, you're operating at C over N values of -40 for the data framing. Actually, the bootstrap operates at a level which is sort of signal acquisition, operates at a level that's 10 dB below the noise floor. So you've got this 40 plus dB range in SNR that at the high end is around about 60, and at the low end is about 1.5 megabits per second. So you have this continuous scale that very closely approximates Shannon curve, which is the theoretical boundary of bits per hertz. But that's for a single waveform. There are MIMO, multi-in, multi-out, which means, for example, the offering of orthogonal waveforms, requiring more sophisticated antennas, a technique that's used in the wireless world, every day today. You can theoretically double the bandwidth for that single 6 megahertz channel, and I think eventually, as ATSC3 progresses and other nations adopt it, countries like Brazil are currently knee deep in the technical evaluation of ATSC3. You've got India, ATSC, the standards organization, the Advanced Television Systems Committee, is setting up shop in India, and very soon the ATSC standard is going to be transcribed into an Indian standard, and so I think there's a whole global activity around this. This isn't just about the U.S. and South Korea. When you do really good work and your good work is recognized, even DVB as an organization has stated there is no reason to try to improve upon the physical layer of the standard. And so the dividing line between the physical layer and then the upper IP layers, it's that IP, it's the transport layer, which becomes a unifier in the minds of many in moving forward with this particular OFDM standard.
These are a lot of new words for a radio guy. I got part of what you're saying, and the 40.
If you have specific word accurate, look at it. Okay, so I'm going to dial it back a little bit. Yeah. I've been living and breathing this for 8+ years, so I apologize to my audience profusely. I will tone down the acronyms.
Well, I heard a number in there. You said the 4096 non-something QAM. I get 4096 QAM. What was the non-something?
Non-uniform. So if you look at a traditional QAM waveform, it's a straight matrix, right? Look at an easy one. QPSK, right? 1, 2, 3, 4 equally spaced quadrant intersect points. 16 QAM is 4 plus 4 plus 4 plus 4, but they're uniform in their distribution.
Right.
So if you believe me, we spent 2.5 years on determining. So if you move away from a uniform constellation and move to a non-uniform constellation, and take into basically take into account the impact of the propagation environment, you can get upwards of 1.5 or more dB improvement in the carrier noise threshold for a given signal. And so 1.5 dB, so it doesn't sound like a whole lot. Mm-hmm. But it's the difference between 60 kilowatts and 100 kilowatts.
Yeah.
So when you start thinking about it in those terms, the ability to reduce transmitter power for the same area of coverage becomes a huge economic benefit.
I got to say, we're going to take a quick break for a sponsor. I'm Kirk Harnack, along with our guest, Mark Aitken, Senior Vice President of Technology over at Sinclair Broadcast Group. And Marty Sacks is with us, too. Marty, I don't know, is your head spinning yet? These are some new terms for radio guys.
Definitely, it makes my head spin. Hopefully, when we come back from the break, we can talk a little bit about why it matters, the whole mobile
Yeah.
receiver aspect, and what the RF plants look like for ATSC3, and we can get back to the some of the stuff some of us grew up with, right? Transmission lines and antennas and all that kind of stuff.
That's what I'd like indeed to get into next, and you'll be asking that. I'm only becoming familiar with some of these ideas about QAM and the size of an array from setting up IP radio links, and because those give you some display of that kind of thing. So there's a lot of technology here that is able to push a lot of data over fewer and fewer hertz. Bits per hertz keeps getting better and better. Our show This Week in Radio Tech is brought to you in part by our friends at Broadcast Bionics. They make software and systems that really help broadcasters to put out much better content and more of it. We're going to hear from Broadcast Bionics. We'll be right back.
Hi, I'm Phil from Broadcast Bionics in the UK, and we've been helping broadcasters and podcasters to work remotely for some time. But in 2020, this has become more of a necessity for many. Xscreen, Bionic Studio and our other products can be fully functional via the internet on a VPN connection or RDP session. If you have any type of Telos VX, HX6 or IQ6, you may already be using the free edition of Xscreen 2, giving you a software interface to go alongside your VSET controller. The subscription edition not only adds a cloud database and unrestricted workstation licenses, but also allows the user to call screen using a USB headset. Bionic Talkshow, part of the Bionic Studio, also allows this. Up until now, it's mainly been used for remote broadcasts, but now more and more stations have call screeners and producers working from home or socially distanced offices. The teams can still collaborate, communicate and deliver programming with the help of our tools. Many routers will have a VPN option. Your local IT specialist can help with this. Using a VPN, our workstation client software can be run on a home PC or laptop as if it was running on a machine at the studio. With remote desktop, the software still runs on a PC at the station. Simple port forwarding on your router may be all that's required to then control that PC and deliver the headset audio from another device using RDP, which is available as part of Windows. For technical help, our support team are on hand. You can email them on support@bionics.co.uk. Combined with our Anywhere and Skype TX for radio products, broadcast quality audio can be delivered from contributors around the corner or around the globe. They can even instant message with the shared chat windows and see the now playing information from within the Anywhere remote web interface. For more information, go to bionic.radio. We're helping broadcasters around the world to adapt to the new normal with innovative tools from Broadcast Bionics.
Hi, I'm Kirk Harnack. It's This Week in Radio Tech, episode 528. And by the way, we're really glad to have Broadcast Bionics as a sponsor of the show. They make some clever software and systems to do all kinds of things in your radio facility, especially visual radio and call handling, call screening, all kinds of management of all things behind the scenes. Good stuff. And you can check it out from Broadcaster's General Store, at least in the U.S. Anywhere you go to bionic.radio and get to their website. In the U.S., you can contact Broadcaster's General Store at bgs.cc. So I'm Kirk Harnack along with Marty Sacks here. And during the break, it looks like maybe Mark Aitken, our guest, got disconnected. I'm checking with Suncast. Suncast, is he back yet? Yeah, okay. I've texted him once. And so, Marty, maybe you could talk a bit about what you've learned about ATSC 3.0. There's this new company called One Media that is making it easier to, to aggregate services over ATSC 3, the data channels. And it's kind of looking to me like a model for ATSC 3 might be for TV stations to offer bandwidth to other third parties. What are you thinking about this at the time?
So, yeah, this is absolutely the case, Kirk. And I believe One Media is associated also with our friends at Sinclair. The understanding, and Mark alluded to this during when he was describing the system, but there is quite a lot of thought related to delivering IP to the field using these ATSC3 transmitters. So in addition to the transmission of the program content for a television station itself, there's also bandwidth there for other purposes, to enrich in the viewer's experience, to potentially get bandwidth, IB bits, if you will, out for other purposes as well. And I believe that company that you just described is specifically designed to help, take the bandwidth from multiple, user or multiple stations, multiple companies that own these stations that are ATSC3 upgraded, and sort of bundle that together. And that's my understanding. But again, no expert here. I'm still learning too.
Mark has been able to reconnect. So, Mark, we were just talking about One Media and what you guys looks like you're doing in the Seattle market, beginning to put audio services onto your ATSC 3 signal. Mark, are you? Oh, yes, you're back. Good.
Yeah, I'm back. I apologize. I have not seen the blue screen of death in 2 years, and it scared the crap out of me.
Oh no! Well, I'm glad you're back, and wow, I haven't seen a blue screen in quite a while myself. So, Marty, maybe there's a question you'd like to tee up specifically for Mark at this point, and Seattle might be a good place to start because they're actually doing it there.
Yes. So, Mark, what would be interesting, I think, is to understand some of the differences on the RF side and some of the differences on the listener experience side for ATSC3.
Sure. Well, I mean, on the RF side, there have been improvements in amplifier design. I mean, when I started out in the industry, you had tetrodes for FM, you had klystrons for television, and then we went to more advanced tubes in television, like inductive output tubes, which were a combination tetrode, klystron, and now all of the transmitters that are being deployed are solid state, although they're configured a bit differently because, in fact, there's a peak to average ratio that changes the sweet operational point of an amplifier. You think a Class A, is a straight linear amplifier, if you will. Class, you've got Class B, A, B, Class C. Well, current solid state designs accommodate good efficiency for the average power, but reserve capacity to reach the peak power envelope of a digital signal, which is for OFDM about 10 to 11 dB peak to average ratio versus about 8 dB for 8 VSB. So current transmitters are able to operate more efficiently, and we're designed for this peak to average ratio. But any amplifier can accommodate the waveform. It's just a matter of back off. People involved in microwave links or satellite will understand that notion of having to back off to a linear range, which reduces the effective range that you can cover. But in Seattle, you still have a transmitter, you still have a transmission line, you still got filters to shape the shoulders of an amplifier, transmission line up a tower, and antennas, and those technologies are, thank goodness, at their fundamentals, they've not changed since the invention of radar, at least for television. So it really comes down to, we talked a little bit about waveforms, but when you get into this convey data, and you're right, everybody thinks of this standard as a television standard, but I can assure you that we were involved in the very fundamental stages of developing the standard, and we always saw it as a data agnostic digital standard. And television is one of the things that it can do, and it does it very well. And you couple that with video codecs and audio codecs, and you can increase the experience. All of those, feed those big, those big beautiful screens with big beautiful video and hopefully a decent audio system. And my first love in the electronics realm, by the way, was I was a bit of an audiophile as a kid. But so sound is in many ways, by the way, people will tolerate really poor video as long as they have audio. So first and foremost, if you don't have audio, you do not have a television experience. I think that may be a very low bar and threshold, and we certainly have extremely capable audio codecs associated with the standard. But you have to think of this as a broadcast standard, and that's why the idea of television and radio, when you start thinking of radio in terms of the digital layer of radio, it comes together at that IP level. And it doesn't matter if you're talking about any of the digital standards that are out there today in radio, or if you're talking about the audio standards that are available, that are associated with with today's modern video standards. So once you realize that what you have is an IP pipeline, then you start thinking about, well, what are the things I could do? Well, I think one of the key elements of this standard that has to be understood is that we have a runtime environment, as it's called. It's the ATSC A344 standard. But what it is it's a browser. It's a browser. If you think of it in terms of a Mozilla, of a Chrome, of a Safari, right? All take the same IP. They all have a different underlying operating system, whether it's iOS or Android or WebOS, or it doesn't matter. Universally, that IP data converges around a runtime environment, a browser environment that holds all of the IP data. So when you sort of forget about UHF and forget about the specifics of the physical layer and start thinking about the IP layer, what you immediately begin to understand is that the tools, because this runtime environment is built on literally the same tools as the web browser that I'm using here today, or that any one of your viewers today is using on any device. HTML5, WC3, ITEF, all of those acronyms, that are IP web-based acronyms. This is a standard that is totally converged at the IP layer with the internet. So if I can do something with IP data anywhere, theoretically and demonstrably, I can do it inside of this standard. So I'll talk about Seattle as a specific because it's really, we're taking a three-phase approach to our audio-only services. The initial implementation takes advantage of this runtime environment and what I would call a broadcast app. What's a broadcast app? It's a small file. If you've got Mozilla or Chrome, every once in a while you'll come along, particularly with a fresh, a fresh software load. Do you want to download this player? Do you want to download this extension? Well, they're all operating in that specific browser environment, but it brings new capabilities. It's not, the framework is the same, right? The operating environment of the browser is the same, but I add an extension to it. And so a broadcast app, which occupies a total payload of about 1.5 megabits. We carve out a channel, for non-real-time file delivery, and every couple of seconds, we're sending out a broadcast app, an extension that does many things. It allows us to populate, first in the smart TV environment, populate microsites. So first thing that happens is your remote control becomes actually a navigation device for a television: up, down, left, right, and enter, center. So now, I want to launch the broadcast app. I push the center button on my remote control, and suddenly a new pane comes out, just as it would on the internet. My television, my video service gets squeezed back a little bit. I have a new pane of information, and now I can navigate. So into that environment, we've leveraged Stir Audio, and we're running 15 audio services. Now, those are all microsites. We do the same thing with news and weather and sports. An item's up, there might be a graphical of of the event. It might be the weather map, depending on what tab you're on that screen. But all of these things that people are doing every day on the internet now come into the television environment, and you build off of that. So now you've got in Seattle 15 different audio services. Well, there's streaming services, and they're actually coming in the smart TV environment, the connected TV environment, coming to the viewer. Phase 2, we own in Seattle, we own 4 radio stations. We're in the process of bringing that content into in-band carriage. It's not an out-of-band experience, which means that any device that can receive will get this radio service. And we're starting with the easiest thing to do, which is we're going to encode that in AC4, because television sets, the NexGen label, for the television side of our business, says that these sets will all support this minimal set of requirements, and AC4 is one of them. In other parts of the world, South Korea, it's MPEG-H. It's a different audio standard, but it's just a firmware difference between television sets. So we're launching in about a month this in-band radio service that will include in-band carriage of radio stations. But the third phase that we're working on is delivering through that broadcast app, delivering a player for an audio standard that is not specified in the ATSC 3 or the A300 suite of standards, and we will be taking enhanced XHEAAC, enhanced HEAAC, and begin using an actual radio player. In many parts of the world, some of your radio folks will certainly know that digital radio mondial, used in AM and shortwave because of the need, the fact that you have restricted bandwidth capability drives the need for an extremely sophisticated audio codec. And you can do decent stereo. You can do sort of Sirius XM quality, and I'm not saying that that's high quality, but you could do Sirius XM quality stereo services in about 25 kilobits. So we're not we don't need to be in the radio business. We're in the bit distribution business. That's how we view what we do and what our future is. It's bit distribution. We'll be selling capacity, but why UHF? Well, UHF, we've developed a phone. In another part of by my life, I'm managing a chip firm, a fabless chip manufacturer in India, Saankhya Labs, and in this actual phone is that chip that we're in the development phase. We've got dozens of these phones today. We're getting ready to release evaluation copies, which means with hundreds of phones to go out across broadcasters and others who would be interested in having a device which is mobile, which is portable, which can convey IP, and the use. The reason that we're focused on audio is there is a huge opportunity in India where the government has decided that it needs to, it's got to rebuild its radio infrastructure, but AM and shortwave and even FM is difficult to receive in these small devices, simple physics, but everybody has one of these. And so if this becomes, through UHF spectrum, the conveyor belt, IP digital conveyor belt for digital audio, it becomes available to everybody, provided they have ATSC3, chips in phones, so to speak. So that's probably too long of a conversation, but that's sort of, we've got a path that we're mapping out, and we're going to be demonstrating. We're rolling that broadcast app out in every single market that we're hosting 3.0 signals in. And it's if for nothing else, it's to show that this is not just a television standard. This is a broadcast.
So Mark, question for you on this topic. So the story here is that you're describing using the phone as the new radio. What does it look like in terms of the single frequency network aspect of this? There's been some talk about SFN and its future here in the States, and I'd be very curious to hear what you think about that.
Well, just 2 days ago, the FCC, did a reconsideration on it's called the DTS standard, distributed transmission services, and it was that acronym equals SFN. That acronym was chosen because 8VSB is different than OFDM. There were a lot of restrictions on what we could do. We didn't want to, at that time, 12 years plus ago, when DTS was standardized, we didn't want to confuse people with the notion that it was a real SFN. Today, with OFDM, it's a real SFN. And what that means is it really allows us to provide a uniform quality of service across our entire FCC-defined coverage area. There is one of my pet peeves for almost 20 years now is that we're handed this thing that's called coverage, and the same thing applies for FM, by the way. It applies for any service that the FCC licenses. They in the case of television, they're literally taking data that was derived in the late 40s and early 50s and sort of put into a regulatory rulemaking in 1952 based on TESO, as it was called. But what was it? It was a study of propagation that was done with diodes and slide rules, and so they use that same modeling. The 50-90 curves, 50-50 curves, all of these time, location, variable probabilities, and they say, here's your coverage area, right? And what it turns out is that's really sort of your franchise, but what we know is that our actual sys inside of that coverage contour is much less than the service contour. So SFNs allow us to take that big circle, which actually, has some blotchy areas of coverage here and here, and deploy secondary emitters, secondary transmission systems to fill those areas in. And with OFDM, you can do that and actually define a time offset between the arrival of signals and use the entirety of that overlay to increase the probability of service. You raise the RF level, you get past the shadowing of buildings in urban areas. You can avoid the impact of reflections in those urban areas, and you can put together a consistency in coverage. And when you have, I don't know if I can even show graphic, but if you've got a tall tower, high power, you've got this scraping effect, if you will, of signal level out to the edge of coverage. And in UHF, that's pretty much the radio horizon, plus or minus 50 miles. Well, as that falls off, if you want to provide a uniform service, based on our earlier discussion, it means that you have to give up bit capacity to get service out to the edge. But if you have an SFN, it's kind of like multiple tents, right? So you string together a series of tents, and what you have is at the base of all of those tents, you've got a service level of RF that is uniform, that allows you to offer a high quality of service at a higher bit rate. So from a spectrum efficiency standpoint, SFNs buy you the ability to provide uniform service at much higher day rates.
Yeah, that's fascinating. And maybe Mark.
Oh, and by the way, that also means that the urban service that we may have today with in building penetration, because you got a lot of power in that 10, 15 mile radius, that first low of a transmitter antenna pattern. But you start extending out because of the lower RF level, the lower signal level. You don't have indoor building penetration. You build out fan and you build up the level of RF signals, and you can provide uniform service not just out of doors, but you can begin to tackle simple reception devices inside of the home.
That's fascinating. And one more question from me before Kirk takes the microphone from me. So I got to be quick about this. I guess I'm very curious about the actual user experience. So a lot of us that listen to this podcast are audio folks, and you talked about your background in the original days of your career as being very audio focused. I'm just curious as to what we can expect from ATSC3 from an audio standpoint, specifically as listeners. So, if you could talk a little bit about what AC4 brings and immersive and some of these kinds of things, that might be very fascinating to our audience.
Well, sure. Look at you have immersive sound, and you have sound as objects, if you will. You have new tools that become available to users in every audio environment. But if you look at the reality of the television environment today, almost universally, people care even a TWiRT about audio quality, are buying a sound bar so that they can get a better overall audio experience. But you have immersive sound, which is in the case of AC4, you've got 22.2. You've got the ability to do literally, if you've sat through a demonstration. I can remember some of these at Dolby. It's like, not only does are you looking at 4K? I'm in the middle of a jungle, but I'm hearing every event that's going around me. But in the first stages of marketing, if you will, that NexGen is making, they are making a big deal about some of the levels of control of sound that you have. And, if you think of it as the sound stage, so to speak, one of probably the most important controls is the speech track, if you will, versus ambient sound. The ability to control, if you will, the nature of ambient sound versus think of a NASCAR event, for example. A lot of people love NASCAR because they love that rumble of the engines as they come, as they start up and come speeding by. Well, you got an intense audio system with a good subwoofer or two, and you can control that ambient sound and create for yourself the sound experience that you want. So it's three-dimensional, if you will, but it's wholly dependent on the origination material. Although some of the firms, companies that Telos works with, Linear Acoustics and other, are really good at synthesizing a broader soundstage and adding a depth of realism. 5.1 is AC, AC3 5.1 sound is the standard that of today. But I think in the future, as listening devices increase, you can buy earbuds today that offer multi-dimensional sound. So I think that we can bring a high quality audio experience, but again, we intend to be the radio service provider. Just think of us as the transportation. We will have bits for bucks, so to speak, but at rates that are lower than even wired ISP services in the home. Just the nature of broadcast one-to-many adds a whole different dimension to the kinds of bits and the services that they can offer, differentiated from unicast one-to-one bits.
Right. So you get that broadcast action going on. Go ahead, Kirk.
No, this is absolutely fascinating. I wish we had a 2-hour show today, but we don't. You're listening or watching to This Week in Radio Tech, episode 528. I'm Kirk Harnack. Marty Sacks from the Telos Alliance is my co-host today. We're talking about ATSC 3.0 with Mark Aitken. He's a Senior Vice President of Technology over at Sinclair Broadcast Group, and they have been really pushing ahead, moving ahead, along with a few other broadcast groups to get ATSC 3 out there and figure out, what other uses there are for this IP highway in the sky to get bits out to people and do the most with them for entertainment, information purposes. Who knows? Maybe remote control of devices. There's a lot of possibilities out there. We're going to end up talking on the show about a few of those other possibilities. Our show This Week in Radio Tech is brought to you in part by my friend Hank Landsberg over at Henry Engineering, and this newest product from Hank. It's only been out for about a year, so if you haven't heard of it, don't worry. I know you've heard of the Super Relay, right? It's been out for like 30 years now, and everybody uses a Super Relay in their radio studios to light up the light over the door, the on-air light, or turn on some other warning lights, or even remember the days when we used cassette decks to do your logging, your telescoping, your air check tape. We used to hook that through the motor of the of the cassette deck through the relays on the Henry Super Relay. Well, this is the new version of the Henry Super Relay. Now, they still do have the Henry Super Relay, but you know what? If you're just going to be running some LEDs on your on-air light above the door, or those rings, those LED rings on your mic arms, this is what you need. This is the Henry Super Light. And it's only, like I said, only been out for about a year. If Suncast has a chance to show the web, oh, there it is. There's the web page right there. The Super Light is designed to do exactly what you need to do. It's for controlling low voltage studio tally lights. Now, it can directly power a 12 volt DC LED tally light up to half an amp, up to 500 milliamps. It does include, just like its older brother, the big brother, the Super Relay, it includes a flasher circuit, as well as a double pole, double throw relay output that can be used for any low voltage switching or speaker muting or other utility use. Yes, you could even control the motor on your cassette deck for doing an air check. The LED output can supply 12 volts DC at 500 milliamps, and it can also sync up to 2 amps externally if you're using it with an external power source. So if you've got a lot of LED warning lights, you can still use the Henry Super Light directly. Just use an external power source. It's got the convenient Euro blocks on it for the inputs and the relay outputs. And it's got this really convenient feature. It's the Control Link I/O. The Control Link I/O are these two RJ45 connectors on here, and they let you, in fact, if Suncast wants to scroll down to the bottom of that page, they will let you daisy chain several of these together, but they don't have to all, there you go. Look at the multi-studio looped through Cat5 control cable. Now, that doesn't mean all these studios lights come on at the same time. No, they're still controllable individually, but you can control them from one area. So let's say you've got an audio over IP system in your radio station and you have a GPIO node in your rack room. Well, now you can conveniently just wire the GPOs from your on-air lights, your audio consoles, into some Cat5 cable and run that Cat5 cable from one super light to another and control your studio lights. Hank Landsberg really tries to figure out what's going to make it convenient for you to wire up your studios. And that's why Hank has so many products just to help you get things done more quickly. These are products on the website, henryeng.com, henryeng.com, and look up the Superlight. That's this product. Now, when you're ready to order, when you're ready to buy any Henry Engineering product, you know where I'm going to tell you to go. Contact Broadcasters General Store at bgs.cc. That's their website, bgs.cc. And you can find lots of product information there, but I got to tell you, my friends at BGS are terrific on the phone. They do good phone. I just talked to Hugh today from Broadcasters General Store. So give them a call at 352-622-7700. And if you order broadcast equipment like I do, you'll soon memorize the number too. They have sharp pencils there at Broadcasters General Store. And you know what? When they give you a quote, it's really nice. They show you all the list prices, and then they show you the discount. So you can take that quote into your boss and say, look, here's how much I'm saving you with Broadcasters General Store. Check them out at bgs.cc. Thanks a lot, Broadcasters General Store, and Hank Landsberg of Henry Engineering for sponsoring This Week in Radio Tech. All right, Marty, I think we wanted to move right ahead with some more questions for Mark Aitken. What did you have in mind about, was it user experience or what we can expect from radio audio services or what, Marty?
So what I thought, we talked a little bit, Kirk, just now about the enhanced audio experience made possible by NexGenTV. But I was wondering if you wanted to tease out that little discovery we made right before we started today about a very popular transmitter company that all of us are familiar with.
I mentioned that we just found out that Mark has experience with a transmitter company that all of us know about. If you've been an engineer in broadcasting very long at all, you know about. I'll tell you who it is. I'll let Mark tell you who it is in a second. And this company went through several iterations. I was most familiar personally with the last iteration when the company moved to a southern state. But for years, the company was in, I believe it was Cherry Hill, New Jersey, and Mark was with it before that. Mark, tell us about this transmitter company.
Yeah. My first job was CCA Electronics, and I actually CCA Electronics gotten into television by purchasing the Ampex broadcast division, and so Ampex broadcast became CCA, and CCA, had a relabeling, if you will. They were getting into the UHF business. I won't talk about the shenanigans that were going on. With a Greek military general and the junta and offshore activities. But I'll suffice it to say that I moved every single drawing file and a large part of the warehouse of CCA from Westfield, Massachusetts to Cherry Hill, New Jersey. And shortly thereafter, I actually went to work for Comark, and Comark took on a lot of the support activity for CCA, and I became actually the product manager of their FM antenna product line. And through Comark, we developed a number of other RF, FM, and radio RF products. But certainly UHF was sort of the new opportunity in the industry, and Comark went after that. But so I knew Bernie Wise. I remember going down to Bernie for a period there, sort of in the interim. He was running a couple radio stations down in Florida, as I recall. Yeah, interesting intersection of background.
I think half the people in the industry have.
But I will let me add to the question that was asked about the user experience.
Yeah.
Once you have this ability of basically replicating an internet experience, it really is a matter of how many bits do you want to commit to that, and how do you want to build off of that. Some of the easiest things are to imagine. We've got digital radio today. So you got an album cover that shows up, in the automobile. Problem is that that's not available on these small devices. Physics precluded. The NAB tried valiantly to get, the chip in the phone mandate for FM for radio through, but when suddenly this device is connected with an earpod wirelessly, you've got no antenna, and so it sort of falls down. But now, so build off of that. Not only can you provide, the name of the recording artist and the record and the album and noticeable graphics, but you could actually on a device that has a return link like a mobile phone, you can begin. You can create a paywall if you wanted. You could sell directly to the consumer. There's certainly a competitive landscape out there that I think is really really destined to bring some new players into that field. And when you tie that to the video side of the capability, imagine radio working in conjunction with with music venues, and live concert events are brought to you by a linkage through the radio application on that device. So all these things become possibilities because it's IP protocol, and so link me to the site of your choice, either carried in band with an IP address or out of band as a traditional IP address. But all of those things are possible, and literally all the tools that are available on the internet come to broadcast.
Marty, I don't know. We've had a lot of big talk here. Some new technical terms, some amazing data rates, and then some high-level ideas about what can go over ATSC 3.0. I guess I should ask. You mentioned, Mark, about your involvement with a chip fabricator in India, and you showed us the phone that you have there. When can we expect some more consumer devices that would let us do more than? I guess there's a few TVs either on the way or just appearing. What else can we expect in terms of the user experience? What can I carry around? What can I lust after for my next thing to buy to get some of these cool over-the-air services?
Well, we're having conversations with a number of MVPDs. These are virtual network operators, mobile virtual network operators. They're buying bandwidth today from AT&T and Verizon and T-Mobile. And as a matter of fact, this phone was designed with a SIM card that'll operate on the AT&T or T-Mobile network. So our conversations with the MVNOs is about distinguishing the services that they offer to certain demographics, and offer live broadcast as the first piece of that. At the same time, we've got conversations. A couple of the radio groups have started conversations with us. They when we go live in Washington D.C. in the March timeframe, we've already begun to reach out to the top radio stations. Our intent is to carry those top radio stations as one of the services inside of 3.0. In many ways, we're sort of the chicken and the egg. We're deploying the transmission infrastructure and some of the foundational services, and at the same time, we're feeding into the device universe. You've now got dozens of television sets. You've got gateway devices, as they're known, coming to market. One of the most famous ones was the HD home run through Silicon Dust. It was actually a Kickstarter project that raised something like 10 times what they were looking for to develop a gateway product. And what's a gateway product? Takes ATSC3 RF in, demodulates and outputs an IP stream that can flow across the home network. So, instead of having to have a device that has a chip built in, I can take my device, whether it's a phone or a tablet, anything that operates on Wi-Fi. I can take those over-the-air bits, bring them into the home, distribute them across through my home network in Wi-Fi, and see that content on any device that has a browser with an ATSC3 application and has network access. So,
if I can get Suncast to take my, here we go. This is a Silicon Dust ATSC 1.0 tuner that's in my server room over there. And this is live. This is the Sinclair station here in Nashville. They're running Jeopardy right now. And I'm picking this up over my Wi-Fi. Now, this isn't appropriate to run over the public internet. I'm getting absolutely full ATSC 1 bandwidth across my Wi-Fi into this phone. So the quality on this is just absolutely amazing.
Yep. So begin dreaming about how that gets extended. And suddenly that kind of a gateway device is something that's in the car. I'll tell you, my wife, if she had that and could feed the back screens in our in our Chrysler van, the grandkids would be a lot happier on some of the road trips.
That's great.
Yeah. And
that is great.
You got to keep the grandkids happy. Hey, we've got to take one more quick break. Be back with a final tip. I'm going to ask Mark to think of what's a final tip, and maybe Marty, you've got a word of wisdom for radio broadcast engineers and station owners and program directors to keep their eyes open about ATSC3 and how their radio stations might be able to interact and get on some bandwagon here. I'm Kirk Harnack. It's This Week in Radio Tech, our 528th episode. I'm along with Marty Sacks from the Telos Alliance and Mark Aitken from Sinclair Broadcast Group. He's the Senior VP of Technology there. Our show is brought to you in part by our friends at Angry Audio. Remember, don't get mad, get angry. And I know you've heard me talk about this and kind of wink, wink, nudge, nudge, tell you that what I love about this headphone amp, it can mount under your tabletop. It's got some little rubber feet right there that keep everything all nice and tight and spongy. And it doesn't sit here and rock. Just put 4 screws in it. And put it up under the desk, and it's got both kinds of headphone jacks there, country and western, as I say. It's 1/8 inch and the 1/4 inch headphone jacks. Nice and loud, if you need it nice and loud, volume control right there. And look how curvy it is. You won't snag your pantyhose on this headphone amp. Nope, it's nice and smooth. And on the back, look at this. It gets power from a 16-volt AC wall wart right over here, or it can be powered from another one of these, and you just daisy chain them. And the daisy chaining is for the power and for the audio. Just use Cat5 cable, RJ45 connectors. It's analog. It's just, balanced line level analog from one to another. And this can make wiring up your studio for multiple mics so easy. Even if you just have one mic, though, this is a great headphone amp. And of course, you can wire it all together with the Studio Hub products available also at Angry Audio, because they bought the company. They bought Studio Hub. They bought the jigs. It's all made in the same factory as it always has been. And that means the Studio Hub gear, remember Studio Hub, Dan Braverman invented this stuff and really got the manufacturing process down very, very well. This is audio cable, but look, it goes into an RJ45 connector here. And then at the other end, you can order this with whatever connectors you want. In this case, here's some female XLR connectors, but you can get male XLRs, quarter-inch tip ring sleeve, bare wire, RCA jacks, plugs if you want. And this, so if you haven't wired with Studio Hub, you are missing out because you can get your wiring done so fast. In the last 3 years, I've wired a couple studios at my Mississippi stations. And you know what? I forgot to order just one of these. I had all I needed except one. And I had to break out the soldering iron. And man, was I just ticked off because I had to solder some connectors on, but to some cables that I had to make. These are great. If you've ever used them before, you know how terrific they are. Here's the other way to do it with the male RJ45 on there, and this would be for something really close to wherever you're going, to your X node or whatever it is. Check it out at angryaudio.com, angryaudio.com. There's the website. Remember what they say, don't get mad, get angry, and problems do disappear when you get angry. Thanks a lot, Angry Audio, for sponsoring the show. We've got a quick word from Gary Morrill at Max Connect, and we'll be right back.
I'm Gary Morrill, Midwest Regional Director of Engineering for Alpha Media. When I first spoke with Josh Bone about Max Connect, he told me they'd work great for remote transmitter sites where connectivity was a challenge. And he's absolutely right. We even have sites where we're using this as a backup to our STL using Max Connect's dual carrier option, and it works perfectly. We also have times where we need to be able to get out to a venue where it's kind of challenging because everybody and his brother is trying to stream video at the same time, like at a big sporting event. And you know what? Our data gets through every time because it's prioritized packet data. It works for us. It'll work for you. Max Connect. Check it out.
And you can get Max Connect through several different LTE modems. Contact Max Connect Wireless, and they'll help you out. This one happens to be the one from PepWave, but also we have one from Cradlepoint. These are just terrific. They'll get you that prioritized data and get you a remote broadcast on the air with a fixed IP address. It's your alternate way to get to your transmitter site and access remote stuff. Thanks a lot, Max Connect Wireless.com. There's the funny spelling. So look for it in the show notes if you can't remember how to spell that, but you know how internet names are. Hey, it's Kirk Harnack. Marty Sacks from Telos Alliance is along, and Mark Aitken. Mark, we've just got a minute. We've got to buzz out of here. As they say, the news team is on the way in. What? There's the AV Club. Love it.
Audio.
What's that? Audio
first.
Audio first.
Audio
yes.
first.
Audio first. Thank you. Thank you. Mark, any quick last word for us before we have to go?
Yeah, ATSC3advocate.com. We've got some educationals on there. We're beginning to put together a whole series of educationals. Also for SBE members, I'll try to remember to get this out to you. But SBE has got some great educationals that we put together. A day-long seminar at NAB the last time we could actually go to NAB, and it's been great being here. You're going to have to do a part 2 at some point, Kurt.
We are. We barely scratched the surface, and I'll put that website in the show notes, atsc3advocate.com. Good information there. You can download and get hold of a lot of good info there. So, Marty, any quick last word from you before we say goodbye?
Hey, thanks for having me, Kirk. Great to spend time with you as always, and Mark. And we have more CCA stories we can tell off air, I think.
I think so. So.
Yeah, I think most of them would have to be off air.
That's great.
Oh my goodness! Hey, we've got to run. Our producers got to go, and like I said, the news team is in next. For those of you network affiliates staying with us, our show This Week in Radio Tech brought to you by some great sponsors. Please patronize them and let them know you heard about them here on This Week in Radio Tech. My thanks to Marty Sacks, the Executive Vice President for Sales, Marketing, and Support at Telos Alliance, and also to Mark Aitken. Big thanks also to Suncast, our producer for the show. Really appreciate your hard work today. And also to Andrew Zarian, the founder of the GFQ Network. Well, you'll find lots of other interesting podcasts, one of them about technology, too. So check it out. What the Tech on the GFQ network. Next week, we've got a great show for you. A friend of mine who knows all about safety and fire protection he spent a lifetime in fire protection for commercial people, and he was a broadcaster himself, too. So he's got broadcast stories and how to keep your facility from catching on fire and going away. That's next week. Dean Wilson is our guest next week on This Week in Radio Tech. We'll see you. Take care. Bye-bye.